So now we're going to look at the standard computational thinking. This is kind of a hard one because we automatically think, oh, well, this means they need to know how a computer works and what the different types of software are there. It's not so much that. So let's look at this a little bit deeper. I love how ISTE explains computational thinking. They say critical thinking plus computing power equals making decisions and innovative solutions. We use a lot of these computational thinking activities every day in class, but when we put it with computers, it totally takes it to a different level. So the number of computer science graduates have decreased by 70% since its peak in 2001. It's a huge number, and it really comes down to we're not producing students who are ready to go into this field because they can't solve those problems and answer those questions, and they've never been exposed to it. It's a nerd thing to them, and they didn't get exposure as young children before they made stereotypes. So new statistics have showed us that 90% of parents want their students to have exposure to computer science while in school. Not just like a little computer class where they learn how to keyboard. They want them to actually learn how to code or how to look for algorithms, those type of things that will help them in their future. So let's look at the standard. Students develop and employ strategies for understanding and solving problems in ways that leverage the power of technological methods and develop and test solutions. That's a lot of words, so let's look at the different components that go with it. Okay, so this says students formulate problem definitions suited for technology-assisted methods such as data analysis, abstract models, and algorithmic thinking in exploring and finding solutions. That's a mouthful, so let's break it down real quick and let's look at the first one. So let's look at technology-assisted data analysis. So this is as simple as putting something in an Excel spreadsheet and being able to make a graph with it. It can be going online and finding different information to make a graph about. But being able to actually put those in order and being able to pull out a product is where we want to go with that. So what is algorithmic thinking? Algorithmic thinking is taking things step by step to complete a task. Think about the old days when you used to have to write the how-to stuff and you had to do how to make a peanut butter jelly sandwich. You had to take each step very detailed. Well, algorithmic thinking does the same thing, but usually we try to use computers or coding to make those steps work correctly. So this one really says that students use technology to actually go through and find data and model their thinking and then use it to solve a problem or to figure out what the problem is. But through that process, they are going to find those solutions that they are looking for. It could be through making the little guy move through on a coding app, or it could be using a formula in Excel.
Students can collect data or identify relevant data sets, use digital tools to analyze them and represent data in various ways to facilitate problem-solving decision making. So that's just a long way of saying that we can use technology to bring in data. You can also take that data and do things with it, like the math I'm showing here. We can take it and help us with problem solving. We just don't jump to answers. We actually use the information that we have gathered. So students will understand how automation works and use algorithmic thinking to develop sequence of steps and create and test automated solutions. So this could be something as extreme as engineering and computer science programming. But it could also be something as simple as using Scratch to make a presentation or using Tinker to learn how to do math problems. So there's the simple coding that allows students to do programming by using commands, and you drag and drop them in. Code.org has fantastic lessons on this. They also have a different programs where you can go and you can learn how to code without computers, just teaching these mindsets that we've talked about here. So that would be a great place for you to start learning about code. So So Tinker and Codable are great for young students. You can actually go in as a teacher and make lessons, and then you choose your lessons based on your math standards that you are trying to teach. You can see how basic, if you look at the picture here, how basic it is to make your sprite move, and kids love it. It's fun, and it's a great way to teach sequencing and a lot of different math skills. So Scratch was developed by some MIT students to teach coding, and it is fantastic. You can have cartoons that move across the screen, you can make video games, you can make all kinds of just whatever your imagination can come up with. And all you have to do is just drag and drop in those codes. I've seen a lot of really cool social studies and science teachers using them for presentations. These little things are not things you would use in your classroom every day, but there are a chance to actually expose these kids to computer science and how to use this thinking that is a totally different problem solving than they're used to. Use the Hour of Code links, use some of the code links below, and see if you can come up with a lesson where you can use this in your everyday class.